video, you are expected to find missing values in different base numbers using simple linear equation, simultaneous equation, quadratic equation. In your junior school maths, I believe you were introduced to simple linear equations, something like 2y plus 4 equals to 8, x minus y equals to 2. You were also shown simultaneous equations where two or more equations with more than one variable are treated or solved simultaneously. You were also shown quadratic equation, which looks like ax raised to the power 2 plus bx plus c equals to 0. Example of that is something like x raised to the power 2 plus 2x plus 3 equals to 0. But in this video, you are to learn how to make use of the three types of equation and finding missing values in different bases. Please, one of the major rules that I want you to pick up in your memory is that you are always targeting to convert all the base number to base 10. If you have this in your memory and you know the method of converting base numbers to base 10, that is by expansion. From this, you can be able to do this. Okay, let's start with using simple linear equations in finding missing values. Find the value of a and b in the following equations. 23 in base a is equal to 13 in base 10. 31 in base b is equal to 112 in base 4. Solution. Make 23 in base a to be in base 10 by doing expansion. We will have, I hope you can remember this. A raised to the power 0 is 1. 3 times 1 will give us 3. A raised to the power 1 remains a. Therefore, 2 times a will give us 2a plus 3, which is equal to 13. Now, let's make 2a the subject formula here. We have where this plus 3 move the other side to become minus 3. Therefore, 13 minus 3 will give us 10. Divide both sides by 2. We have, that is to say, the base a is 5. Let's check it. 2 times 5 will give us 10. 10 plus 3 will give us 13, which is correct. Second question. Here we have 3, 1 in base b is equal to 1, 1, 2 in base 4. Okay, the first thing to do is to equate the base numbers to base 10. Make sure that both base b and base 4 are in base 10. Therefore, we have, if for instance you do not remember this, please go back and watch my video on number base 1. 4 raised to the power 0 is 1. 2 times 4 raised to the power 0 will give us 2. 4 raised to the power 1 is 4. 1 times 4 will give us 4. 4 raised to the power 2 is 16. 1 times 16 will give us 16. B raised to the power 0 will give us 1. Therefore, 1 times 1 will give us 1. B raised to the power 1 will give us b. 3 times b will give us 3b. Make 3b the subject formula by removing plus 1. Let plus 1 move to the right hand side of the equation. Is positive 1. When you move to the other sign, it becomes negative. Where divide both sides by 3, we will have, that is to say, the base b is 7. That means that if we say 3 times 7, we will have 21. 21 plus 1 will give us 22. And if you convert it to base 4, it will give us 112 in base 4. I know this is very, very simple. Therefore, find the missing numbers in 7. 7c in base y equals to 116 in base 7. 45 in base p equals to 131 in base 5. 25 in base w equals to 21 in base 8. Let's go for using simultaneous equations. 45 in base a plus 25 in base p will give us 48 in base 10. Also 52 in base p minus 54 in base a to give us 3 in base 10. Also, we have question b to be 12 in base a plus 13 in base b to give us 110 in base 3. And we also have 21 in base b minus 22 in base a to give us 1. Here, I would like you to pay attention. I will be using substitution method. We still have elimination method. We have matrix form method. I also have graph form. Check my video on simultaneous equation proper. That is where I explained how to do it. Yes, you can still use your elimination method to solve these questions, but for this video we are using substitution method. Let's go. Treating the first work by making 4 5 in base a plus 2 5 in base a to be in base 10. B raised to power 0 is 1. 5 times 1 will give us 5. B raised to power 1 is B. 2 times B will give us 2B. A raised to power 0 is 1. 5 times 1 is 5. A raised to power 1 is A. 4 times A will give us 4A. Opening the bracket, we have collecting like terms. We have 2 can divide 4 and 2 can divide 2, and 2 can also divide 38. If 2 divide throughout, I will have this serve as my equation 1. From the second statement, I mean this. Let's convert this to base 10. This minus will make these values to be negative. A raised to power 0 will give us 1. 4 times 1 will give us 4. A raised to power 1 will give us A. 5 times A will give us 5A. B raised to power 0 will give us 1. 2 times 1 will give us 2. B raised to power 1 will give us B. 5 times B will give us 5B. Open the bracket. Where minus times this will give us minus 5A. And minus times plus 4 will also give us minus 4. This side has no sign in front of it, therefore we assume it is plus. Opening the bracket will give us 5B plus 2. Collection of like terms. Where this minus 2 go over here to become plus 2. 5 can divide throughout. Therefore, if 5 divide throughout, I will have, that's become my equation 2. Now, we can make B the subject formula here. B will become, and if we insert this B, or substitute B to be 1 plus A in equation 1, we will have, inserting B equals to 1 plus A in this place, we will have, open the bracket, we have, collect like terms, we will have, where this plus 1 go over here become minus 1, we will have, make A the subject formula by dividing both sides by 3. We will have, but recall that B is equal to 1 plus A. If A is 6, 1 plus 6 will give us what? 7. Therefore, A is equal to 6, B is equal to 7. Let's go for the second question. Here, let's convert 1, 2 in base A plus 1, 3 in base B to base 10. 3 raised to power 0 is the same thing as 1. 0 times 1 will give us 0. 3 raised to power 1 will give us 3. 1 times 3 will give us 3. 3 raised to power 2 will give us 9. 1 times 9 will give us 9. B raised to power 0 will give us 1. 3 times 1 will give us 3. B raised to power 1 will give us B. 1 times B will still give us B. A raised to power 0 will give us 1. 2 times 1 will give us 2. A raised to power 1 will give us A. 1 times A will give us A. Opening bracket. Since this is positive, just remain the same. Collection of like terms. Let number goes to numbers and let alphabet go closer to alphabet. Which forms, this becomes our equation 1. I can make A the subject formula here. Let's go for the second statement of the equation. This is it. A raised to power 0 is 1. 2 times 1 will give us 2. A raised to power 1 is A. 2 times A will give us 2A. B raised to power 0 will give us 1. 1 times 1 will give us 1. B raised to power 1 will give us B. 2 times B will give us 2B. Since there is a negative sign here, minus this will give us minus 2A minus 2. That is by opening brackets. Collection of like terms we have, where this minus 1 go over here to give us plus 1. Join together will give us 2. Since 2 can divide throughout, we have B minus A equals to 1. Remember that A is 7 minus B. We can insert the value there, or we can make B the subject formula. Any of them is possible since they are all singleton in each of the equation. Therefore, let's insert A equals to 7 minus B. We will have, since A is equal to 7 minus B, here minus enter minus 7, minus times minus will give us plus B. Collection of like terms, we will have B plus B minus 7 will give us 1. Where minus 7 go to the other side, we will have, dividing both sides by 2, we will have. Remember that A is equal to 7 minus B. Therefore, we will look for A, where B is 4, will give us 3. Therefore, A is 3, B is 4. You can cross-check it on your own to know if that is correct using quadratic equation. Example, 112 in base p is equal to 24 in base 5. Also, 514 in base w is equal to 190 in base 10. We need to equate this to be in base 10. Therefore, we need to convert 112 in base p to a value or a number in base 10. Also convert 24 in base 5 to a number in base 10. Let's do it. Numbering. P raised to the power 0 will still give us 1. 2 times 1 will give us 2. P raised to the power 1 will still give us p. 1 times p will give us p. P raised to the power 2 will give us p raised to the power 2. 1 times p raised to the power 2 will remain p raised to the power 2. 5 raised to the power 0 is 1. 4 times 1 will give us 4. 5 raised to the power 1 is 5. 2 times 5 is 10. Here you're going to use quadratic formula to solve this so that it will be easier for us. This thing looks more like if we can bring in the 14 from the right hand side of the equation to the left hand side, as which gives us, therefore, a is equal to 1. Using the general formula we have, this will be explained properly in my quadratic equation video. Therefore, for now, I would like you to know that this is a general formula for quadratic equation. Okay, here we are going to insert what a is, b is, and c is. Let's insert it and we will have, if we further this, we will have, which gives us, further gives us, this further gives us, this plus or minus. Let's go with the plus and also go with the minus. We will have, here we go, our final answer will be, but we don't have minus 4 in base number. Therefore, our answer p is equal to 3. Now, remember the reason is because we don't have a negative base. I'm still using the quadratic formula for the next one. Therefore, let's go for the next question. Convert it to base 10. We will have, further we have, now let's bring in 190 to come the other side. We will have, it will yield, which is similar to where a is equal to, going with the quadratic formula, we will have, further will give us, this further gives us, we will try the plus and we'll try the negative, we will have, further will give us, either w is equal to 6 or w equals to minus 6.2. And w cannot be negative value, and also w cannot be a number that has digit after decimal point. Therefore, w is equal to 6. I would like you to try this question. Thank you for watching this video online, and make sure you click the subscribe button for notification on my other videos.